Right, so welcome back to Statistic 2, Poisson Distribution. Today we will talk about how to use the Poisson distribution as an approximation for the binomial distribution. So let's just say we have a question. The question says that 1% of the items produced by a certain process are defective. 1% are defective. Using the Poisson approximation, determine the probabilities that in a random sample of 1000 articles, at most 5 are defective. Now, the probabilities that a certain item is defective is 1%, which is quite low. So 1%, the P is equal to 0.01. 0.01. So this is the binomial distribution. So the P is 0.01. So the mean is equal to 1000 times 0.01, which gets you 10. Right, so the mean is 10. And the mean is 10, and also we can get the variance. The variance is equal to 10 to the power times 0.99. So what was it? 0.99. So 1 minus 0.01 is 0.99. So that's the formula for the variance in a binomial distribution. So here you get approximately 10. So these two are approximately 10. So the Poisson so this is the Poisson approximation would be PO10. So a sign to know when to use the Poisson approximation lies in the probability itself. So if the probability is really small, like in this case it is 0.01, the probability is too small that eventually the mean and the variance will be so close that you can consider this to be a Poisson distribution. Right, so that is the sign. You see, if the P is smaller than 0.1, the N is large, so the numbers of the items is large, which is usually bigger than 50. And if NP is smaller than NP is smaller than 5, usually these three are what you can write in your exam paper to show that a Poisson approximation is a good thing to use. Right, so in this case we are having a Poisson distribution of 10. Right, so now we will solve the problem. The problem says that we need to find probabilities that in a random sample of 10,000 articles, at most 5 are defective. So the P is Px smaller or equal to 5. The probabilities of P smaller or equal to 5, so at most 5 are defective. The probability is x smaller or equal to 5, which is equal to P x equals 0 plus P x equal 1 plus etc. plus P x equal 5. So the mean is 10, right? So this will be equal to e to the power of minus mean minus 10 time. So for x is equal to 0, so this part ahead is always the same, so e to the power of minus 10. So x equals 0, so 10 to the power of 0 over 0 factorial plus 10 to the power of 1 over 1 factorial, 10 to the power of 2 over 2 factorial, plus etc. plus 10 to the power of 5 over 5 factorial. And this gets you equal to 0.0671. So 0.0671 is the probabilities that in a random sample of 10,000 articles, at most 5 are defective. So here is one of the cases where the probability was too low, that the mean and the variance are similar, so that we can use the Poisson approximation to calculate the probabilities for binomial distribution.